let's Math 5130, obviously, I guess. So let's get this data set, get this copied. I've demonstrated this before, but I don't like to take anything for granted. So Control C, take this over. Let's start that right there. And let's do Control V. And then just come in and let's give these some variable names. So BMI, September, BMI, April. And we really don't need these. This is just some differences that I created. So this would be the original data set. So let's save it to our desktop. Let's just call it BMI. And of course, we'll save it as .csv. And again, if I'm going too fast, just stop me. Okay. So let's save it. Close it down. Let's bring that data set into R. Let's find it, BMI. There's a trick to that, which I didn't do too well. All right, much better. Attach our data, or whatever you name this, attach it. And you can see that we have the data set as needed. So first thing I want to demonstrate to you is an independent samples t-test. Now, if I put hashtag that allows me to communicate to you. That tells R that I'm not trying to implement a command. I'm just speaking to my audience, which in this case is you. So I think before we looked at an independent samples t-test, I forget exactly, I think it was BMI April over gender. So FYI, important, gonna yell at you. Very important, when we are working with a categorical variable in R, it is always best to force it to be a factor. I don't know why we used to not have to worry about this in R, but here recently we have. Clearly, when we look down at a variable that's coded with letters, it's not quantitative. R doesn't see that. So what I need to do first, and just get in a habit of this, if you're using R, if I'm going to work with a categorical variable, force it to be a categorical variable. So this is taking sex as it is in our data set. It's forcing it to be a categorical variable, and we've just renamed it sex. All right? Again, that may not make much sense, but please, from hours and hours and hours and classes and classes and classes, I found that to be an issue. So independent samples t-test, I would run t.test. I would put my quantitative variable first, followed by a tilde, followed by sex. Next thing I want to do is I want R to know that I'm not running a dependent samples t-test, so I put paired equals false, and I do not want to assume equal variances. Now, I talked about this back in the first video. We want to run a Welch's t-test. We want to run an unpooled t-test. So when I set variance dot equal to false, I am running an unpooled Welch's t-test. If I put variance dot equal true or a t, Then I'm running a pooled t-test, which again, you never run a pooled t-test in Dr. Darville's class. It's just wrong. So you can see that it ran the Welch's two-sample t-test, which is the equivalent of an unpooled t-test. You can see that we have a test statistic of negative 1.29 or 26, degrees of freedom 52.48, and a p-value 0.2144, just like we did before. Our confidence interval, notice it contains 0, just like it did before. And I like R because it actually gives us the mean, and we can see that the mean for female is less than the mean for male. But these are sample mean differences. And the inference procedure, the t-test, generalizes not specifically to these 67 males and females, but to the population of all males and all females, probably within this school organization. I'm not really sure the context, how the data was collected, but if you're conducting this study, that's something that you would know. Now, easy to run. If I want to run a dependent samples t-test, so let's just run from September to April. So BMI, just like we did previously. And it's got to be typed exactly the way it is in the heading. Deviate from that whatsoever, you get that big old red error, which is not cool. Now, but here we're going to do paired equal true. So hit enter. Notice that the confidence interval does not contain 0. Why? Because we have statistical significance. Test statistic negative 2.95, degrees of freedom 66, p-value less than 0.01. Again, if you need to revisit that video where I taught you how to report p-values, please do so. And our confidence interval does not contain 0. So the mean difference, again, the dependent samples t-test focuses on what? The mean of the difference, not the difference of the means as we did up here. We have two means up here. We just have one mean here. We're seeing if that mean difference is statistically significant and different than the hypothesized value of 0. All right, so again, I just prefer R much over StatCrunch, but StatCrunch mirrors SPSS. It's pretty similar to the way we would do things there, and but SPSS is, I thought, a little bit too expensive for a requirement for this class. I feel like there's something else that I need to share with you here, but I don't know what it is, so we're done. Take care.